Hello everybody, my name is Sabuno Isaac Berry from Berry Science Lab, and today we're doing some exercises from real analysis. So, question 1.
Can I do it in black?
Okay. What? Define Cauchy convergence of xn to be such that for all epsilon in the real numbers that's greater than 0, there exists a natural number big N such that for all m and k that are greater than n, the difference between xm and xk is less than epsilon. Basically saying that for any epsilon that's positive, we can find two different points in the sequence that are closer together than the epsilon length. So the question is to show, well, I'll probably just highlight it, so that Cauchy convergence is equivalent to normal convergence. So, of course, this is our question. Show that Cauchy convergence is equivalent to normal convergence. So, how do we attack this problem? Well, the thing is, equivalent is a very bad word. Why? Because that means we have to go in two directions instead of just one. First, we have to prove that any Cauchy sequences are convergent, and then we have to prove that any convergent sequence is also Cauchy, which makes this a pretty long proof. So let's start by doing the necessary direction. Assume xn is Cauchy so that it's convergent. So that means that there, for any epsilon, so let's say so let epsilon be given, right? So then, by definition, there exists m and k such that the distance between them, sorry, not a, is less than epsilon. All right, so how does this translate into our regular definition of convergence? Well, remember, if something converges, so it's the limit of x to the n is, oh crap, why am I blanking today? As n approaches infinity is equal to L, that means that for all epsilon that are positive, the distance between xn and L is less than that epsilon. All right. So now we have to figure out how this equates to that definition. And to do that, we use what we call the triangle inequality. Now, you probably already remember the triangle inequality from geometry class. If we have a right triangle, or any triangle in general, and we have the two sides A and B, and C is our longest side, then no matter what, C is less than A plus B. And in a very similar, technically less than or equal to. And in a very similar fashion, we can say that the sum of two the sum of two absolute values is less than or equal to the absolute value. In a similar fashion, we can say that the sum of two quantities' absolute values is greater than or equal to, the absolute value of their sum is greater than or equal to the sum of their absolute values. Sorry guys, I'm just looking at my notes right over here. So, given this, what can we do? Well, we know that this is equal to this. So that's xm minus L minus xk plus L. Rewriting it, plus minus xk plus L. So clearly you can see by the triangle inequality, this should be greater than or equal to, the sum of the absolute values, which is this. Oh my goodness, I'm messing up everywhere today. This sign should be negative.
You want to do it again? No,
I'm already out of breath. So we get this. And of course, we already know the absolute value of x is equal to the absolute value of minus x. So we can erase this without much trouble. Meaning that xm minus L minus xk plus L is greater than or equal to xm minus L plus xk minus L. And that is less than, what it was stated before, epsilon, right over here. Oh, sorry, right over here. This is, of course, less than epsilon by the Cauchy definition, which means by transitivity, epsilon is greater than this. So that means that, additionally, each one of these, since they're both positive, has to be less than epsilon, which means that that satisfies our definition for convergence. So that's question 1. Let's move on to question 2.